Welcome back to the Pumps and Systems podcast. I'm your host, Drew Champlin, managing editor of Pumps and Systems magazine. You can visit us on the web at pumpsandsystems.com. Today, we will be talking seal water reduction strategies and improvements in water quality with Ram Venkatadri and Bill Pritchett of John Crane. You can find this podcast at any podcast platform such as Apple, Google, Spotify, SoundCloud, Stitcher, Castbox, or you can go to pumpsandsystems.com/podcasts and get caught up on every episode. We're going to be at episode 80 with this one, so we're moving right along here. The episode sponsor is John Crane. You can visit them on the web at johncrane.com, and you will hear a bit more about them later into the podcast. So let me bring on our guests. First off, Ram Venkatadri. Ram, how you doing?
I'm doing great. My name's Ram Venkatadri. I'm a global product manager with John Crane. I develop new products for filtration specifically. I've been in the industry for a very long time. Been with John Crane for 3 years, but I've been in the filtration business for 15 years. And before that, I worked for power companies and paper mills, as well as oil gas refineries for a while. So I've got some experience to share with you today.
Bill Pritchett, you've been on an episode with me before on reducing seal maintenance costs. First off, how you doing? And tell us a little bit about yourself.
I'm doing great, Drew, and thanks for inviting us to this podcast. We appreciate it. I am currently senior key account manager for John Crane on a global basis. I call on some major OEMs that are represented around the world, generally in the refrigeration industry right now. I started at John Crane eons ago, back in 1979, and have been in the seal industry the vast majority of my career. I also did some work in fluid power. I was a product manager for a Parker distributor, and I also sold industrial valves into the marine industry down in San Diego and Hawaii. My experiences in the marine industry, refineries, wastewater treatment, refrigeration, and so forth.
Well, it was episode 54, actually, that you were on the podcast with me back about a year and a half ago. First off, Bill, let's just talk about the history and trends of sealing technology. What can you tell us about that before we get into the deep water of the podcast?
I thought just touching on the history of seals is always good in case there's anyone listening in, excuse me, that isn't familiar with seals and where they came from. It really started thousands of years ago, all the way back to possibly the Egyptians. Packing, think of packing as engineered rope. Back in the day, it was simply just leather shoved around a shaft and kept the shaft from leaking. Packing has evolved over the years, and as a matter of fact, John Crane was once named John Crane Packing. That's where our roots are from, and we made packing for decades. And then around 1928 is when the first conventional single mechanical seal was invented. Fast forwarding to 1949 was the first automotive water pump seal, which was invented by John Crane. Fast forwarding again to the 70s and 80s, now we're getting into my era. Dual seals became very prevalent, mostly because of emission concerns and safety concerns. Obviously, a lot of these pumps, they pump gasoline and jet fuel and benzene and all sorts of nasty chemicals. And obviously, you don't want that stuff getting out in the atmosphere. SCAQMD Rule 1173, I'll never forget it. Southern California Air Quality Management District came out with Rule 1173, which greatly restricted the parts per million any seal could leak into the atmosphere. Unburned hydrocarbons reacts with sunlight and creates ozone, which is a major factor in smog. And it has been a tremendous benefit to the atmosphere down in Southern California. And lots and lots of single seals are now dual seals with seal support systems. Moving ahead to the early 2000s, we came up with an ultra low flow dual seal. John Crane calls it the upstream pumper. And the idea was where you have extremely difficult applications, think of asphalt or mining industries where you've got a slurry and it just chews up the seal. This seal actually provides its own flush at a very low rate. and we've got hundreds, if not thousands, of applications out in the field now. Around about the same time, we developed a flushless seal. We meaning the industry, and we work in conjunction with the pump manufacturers to make sure that there's a constant flow of pumpage around the seal, so it's not starved. And we can use that in applications up to 2, maybe 3% solids. And the idea, of course, is to reduce or eliminate seal flush. And then finally, just recently in the last few years, we've developed, the industry once again has developed a what we call diamond face, and it is actually diamond that is grown on the seal faces. And it's once again in very, very difficult applications. And that's taking off. The industry is embracing it. One of the side effects or benefits from the diamond face is it runs much cooler than conventional faces, so it takes much less flush. So that's kind of a trend line of some of the technologies. We could go on, but that's at least as far as seal water reduction, that's kind of the trend line there.
Bill, we're going to talk about seal water on this podcast. What is seal water?
Seal water is simply it's used as a lubricant or barrier fluid to cool and keep the faces clean. Think of a seal, mechanical seal, as basically a bearing, in that you've got a stationary and rotating part. And if we'll call them seal faces, if they're not kept cool and clean, they're going to wear out very quickly, just like a bearing. And so a seal water flush is what the primary function of that is. If you have dirty pumpage, if the fluid that you're pumping is dirty, then we use an external flush, water in general. This flush is typically, rule of thumb, is 1 gallon per inch of shaft. So typically, a typical mid-sized pump is 2 to 3 gallons per minute. 2 gallons per minute, for reference, is roughly 1 million gallons of water per year. So think of your hose bib at home outside. Think of turning that on and just leaving it on 24/7, 365. That's how much water a typical seal is using. It's once again, it's to keep the seal cool and clean. The seal flush water is added to wastewater and pulp and paper systems, has to be removed downstream. Obviously, you want dry paper at the end of the process, and think of a wastewater treatment plant as a big dewatering plant. A lot of water comes into it, and the drier the sludge is what they call it at the end, the less cost for the wastewater treatment plant. So any amount of water that you inject into the system, namely seal flush, has to be removed downstream, which all equals cost.
And now a word from our sponsor. John Crane is a global leader in rotating equipment solutions, supplying engineered technologies and services to process industries. The company designs and manufactures a variety of products, including mechanical seals and systems, couplings, filtration systems, and predictive digital monitoring technologies. John Crane customer service is accessed through a global network of more than 200 sales and service facilities in over 50 countries. Visit them on the web at johncrane.com. That's JOHNCRANE.com. And now back to the podcast.
Well, Bill, so what is the primary factor driving the need to reduce seal water consumption?
I think there's 3 major factors: environmental, cost reduction, of course, and certainly out in the Southwest is the current drought, which is not going to get better anytime soon. With 40 million people out there living in a desert, there's always going to be stress on the water system. So the less water industry can use, the more water that'll be available for you and I to use domestically. Ram, do you have anything on that one?
Yes, I do. If you look at the pulp and paper and mining and power gen as industries, these are all very water intensive processes. Now, water shortages, as you mentioned, and higher prices for the fresh water has led to increased recycling. There has also been a large increase in corporate ESG initiatives in reducing water consumption. For example, in some countries, they have what they call zero liquid discharge, which means that any water that you generate as a waste cannot be discarded. It has to be reused in the process. Now, it does make sense, especially in arid regions where fresh water, such as groundwater or surface water, is very limited in supply. I was in a paper mill last month where they were producing a lot of wastewater that was treated in a biological process to clean it up. But even after that process, it was not good enough to be discharged because the regulations are so tight about discharge water. So they were recycling that water to the front of the plant and then mixing it with the incoming surface water. So these are the typical things that you see in industry now, that the recycled water is there and it's always mixed with the incoming water in most cases, and that's how they reduce water consumption. The other point I wanted to mention here was there are very strict regulatory constraints on the kind and quantity of contaminants that a mine or a paper mill, for example, can discharge into their wastewater. So, going back to that point, because of this, they're not allowed to discharge the water without extremely good treatment. So, this means that they recycle most of the water.
Okay, Bill, so what steps can be taken to reduce seal water consumption in the short term?
Well, as I mentioned in question one, the evolution of seal technology, there's many different types of evolution, but as far as the waste or flush reduction, there's 2 or 3 different technologies. There's the diamond face, which runs much cooler, which would result in much lower flush requirements. There's the actual flushless seal design, which is nothing but a conventional seal, but the way the seal chamber is designed, it encourages a flow of the pumpage around the seal to keep it cool, and that obviously eliminates flush. And then we have the, I call it the ultra low flow. We also call it the upstream pumper design, where you take a dual seal and you take the barrier fluid, and instead of 2 to 3 gallons a minute per seal, it's 1 to 2 gallons per day to keep those seals cool and clean. So there is quite a few evolving technologies that can really reduce seal water consumption in a modern plant.
Will, what applications generally consume the most water in a facility?
Well, almost all of them. Typically, like I just said, water is consumed at 1 gallon per inch. That's 2 to 3 gallons per pump. If you have a plant that has 100 pumps, you can do the math. It's a significant amount of water that has to be dealt with downstream. Ron, do you have anything else to add on that one?
Yes, I do. You talked about the water going to the mechanical seals. That's one of the applications, but we have several other process water related applications in all of these plants. For example, they may want to make ultra pure water and they use a reverse osmosis process for that. But the reverse osmosis process requires that the water should be devoid of any suspended solids before it hits the reverse osmosis membrane. Therefore, you need a very good filter to remove the suspended solids before it goes to the reverse osmosis. The other example of process water would be, for example, in a power gen plant where you have these very large cooling towers. The feed to the cooling tower is usually surface water from a lake or from a river or pond, and this water is filtered to some extent before it reaches the cooling tower. But you can see that there's a lot of deposits that are formed in the cooling tower, and that limits the amount of time you can use the cooling tower before you have to shut it down and clean it. So again, an application there would be to use a filter, especially an automatic filter that doesn't require much maintenance. You use that in the line to clean the water going to the cooling towers. So I'm just giving you a couple of examples of processed water that needs to be treated.
What role does water quality play in reducing overall water consumption?
Once again, there's really two factors. One is consistent pressure. You don't want the external water going into the pump to vary much, because you can get pressure reversals, you can get pumpage back up into the water line and so forth. It's just not a good situation. So you want good, consistent pressure. Think of your sink at home. You want that to always be at a certain psi. Same thing with the seal. And the other big factor is cleanliness. If the water you're injecting into the seal is dirty, well, guess what? You're going to wear those seals out soon or prematurely. And as Ram was just talking about, we do have technologies to keep that flush water clean. Ram, you want to add to that?
Yes, the removal of suspended solids in the water is a key requirement to keep all these units working well. And you have a lot of downstream units. Besides the mechanical seals in the pumps, you have things like sand beds and deionizers and reverse osmosis units. All of them have to be given clean water that is devoid of suspended solids so that they can do a better job. So this is where filtration comes into the picture.
Well, Bill, what role does clean water play in cost reduction?
Yeah, it's pretty simple. Clean water allows the seals to last for years, not weeks or months. You just imagine if you have a seal flush that has sand or silt in it, it's going to wear the seal out. It's just that simple. And the cleaner the water, the better chance the seal has of lasting. Ram, you have anything more?
I have quite a few things to say about this. As I was saying earlier, when you reduce the water consumption by recycling the water, you're doing something else too. You're not doing a good job in terms of improving water quality. So because the recycled water is always worse in quality compared to the incoming water in general, especially if you don't treat the recycled water very well. So what do they do now? Filtration is extensively practiced to meet performance goals. So the idea is to first remove the suspended solids in the water to very low levels, say 3 or 4 parts per million. But you also want to reduce other things like iron, manganese, colloids, and bacteria. For a mechanical seal in particular, generally they use a 50 micron filter, 50 micron filter, to protect the mechanical seal from failure. So you remove the solids in the water going to the seal. If you look at the filtration technologies that people are using now, they really belong to three categories. The first category is something that most of you will know. This is the water that is incoming, which goes through what they call clarifiers. And clarifiers are big tanks where they use froth flotation technology, where the solids sink to the bottom and the clean water goes to the top. They also use something called sand bed filters or gravity filters, where you trickle the water through these beds and you clean up the water to remove solids. The problem with these types of large devices is, not only do they occupy a large footprint, they need to be replaced often. The filter media in there needs to be replaced often. And they also have performance issues. So what people are doing now is using them as they are, but supplementing the performance with filters downstream. Now, these filters can be uh, um, cartridge filters, which need to be often replaced as soon as they hit a certain pressure drop. The cartridge filter is useless and they have to throw it out and replace it, which is a manually intensive process. So now they prefer to use automatic filters. these are self-cleaning filters where once your pressure drop hits a certain target or set point, there is automatically a flush of water, a clean water that you collected, by the way. The clean water comes back in and cleans the filter media back to where it was originally. And so this process is continuous. You don't ever have to throw out this filter media. It will last 6 months to 1 year before you have to change the media. So John Crane, for example, has got a new product called a multi-purpose filter, which can filter down to 25 microns and handle fairly large water flow rates. So this will be the second technology that people use, the self-cleaning automatic filter. The third technology is what I had mentioned just a few minutes back. If you need ultra pure water, you use what they call membrane filters, like nanofiltration or reverse osmosis. Once again, if you need very clean water like boiler feed water, you need these technologies. Many of the mills don't have this. For example, paper mills don't have usually some RO units. But some of the plants do. Power plants certainly have RO membranes. The requirement again is the water to these RO membranes has to be devoid of suspended solids. And that's where the earlier filtration comes into the picture. So really, to summarize, there are three different types of filtration technologies that people use to clean up the water.
Well, Bill, let's talk a little bit about trends as we answer the last couple questions on the podcast. What future trends do you see in water savings?
Well, as time goes on, there's more and more pressure on industry in general to reduce water consumption and also wastewater discharge, as Ram has mentioned. Ram, I think you have something about payments and cost on this issue.
There is a new trend that I have noticed. When I walked into a paper mill the other day, they were saying, why should we pay for your equipment up front? The first fit cost for the equipment. We want to see that you meet certain targets for specifications on the water. So we will base our payment on how much you cleaned the water, how long have you cleaned the water to our specifications. So it's what they call a pay for use scheme. So you can base it on a certain flow rate of water that you treated to specs, or you can base it on pressure drop or other parameters. But this is a new trend in the industry wherein instead of paying for the equipment upfront, they're paying for the operating expenditure. They assume that you will meet a certain target that they've specified.
So what trends are you seeing in the industry around water reduction and reuse?
Well, I lived out in California for 30 some odd years, and over the years, more and more wastewater, the effluent, the quote unquote clean water that's coming out of the plant used to just go into the river, down the stream, out to the ocean, whatever. Now they're recovering that, and a lot of times they're using it to water medians in the streets, golf courses, those type of things. It is non-potable water, but it is certainly clean enough to water the grass. There's actually pressure now to start cleaning that water to the point where it's potable, where you could actually drink it. Obviously, there's some resistance to that, but with the way the drought's going out west, you can see where we're headed with that. There's also some desalinization plants that are being built out there. I visited the one in Carlsbad, which is North San Diego County, and it's a very, very expensive way to make fresh water. They take the seawater and filter it and reverse osmosis, similar to what Ram's been talking about, only on a grand scale. I worked on the pumps that suck the seawater in. There's 4 of them. Each one of them has 1,500 horsepower motor. That motor's about the size of a Volkswagen. it takes enormous amounts of electricity to drive those motors, those pumps. And that, of course, drives the water through the filter. It's basically a big filtration plant. And it does produce water, probably enough for a couple good-sized cities, Escondido and San Marcos, for example, if you're familiar with Southern California. And they're planning on building more of those. The problem is when they take that seawater, and they filter it, the salt and grime and so forth has to go somewhere. Well, guess what? It goes back into the ocean. So we're potentially creating another environmental problem, which is getting outside of this podcast. Ram, did you have anything else to add to this one?
Just the same points that I mentioned earlier, that discharge of wastewater to any water body must absolutely meet the local environmental laws. Otherwise, you can't discharge the water. So customers are now compelled to reuse the wastewater as much as possible and treat them before discharging it.
Well, to wrap this podcast up, Bill, how would you say that saving water helps reduce costs?
Well, every gallon of water that is injected into the process stream typically has to be removed downstream. That's certainly true in wastewater and pulp and paper. Mining, many industries have to deal with this water that they're injecting into the system to keep the seals alive, to keep the pumps alive. And then they have to turn around and remove that water. And that all equals cost, right? So the less water we put into the system up front, the less cost for the plant, and that makes management happy. Ram, you have anything else to add?
I did some simple calculations just to illustrate the point. The filter that I mentioned earlier, the self-cleaning automatic filter from John Crane, I used some numbers there to give you an idea how much money you save. So let's say you're recycling 800 liters per minute or 200 gallons per minute of wastewater. So this is the water that you are treating with the filter. And so you're not using fresh water, but the recycled water. So you're saving money for the customer. The typical cost of fresh water depends on where you're located, but typically it's around 0.1 pence per, or British pence per cubic meter. That's like the global standard. Of course, it will vary. In places like California, it'll be 10 times more than in the Gulf Coast of the US. Anyway, if you use that number, we save something like 115 pounds a day, or about $130 a day, and you save about 42,000 pounds per year or $50,000 per year by using this filter. And you're using recycled water instead of fresh water to treat. So just wanted to give you some idea that you will save a lot of money by doing this.
That's a good way to wrap up this latest episode of the Pumps and Systems podcast. Ram Venkatadri and Bill Pritchett, I really appreciate you coming on and sharing your time and your expertise.
Thank you very much.
Thanks for inviting us, Drew.
Sure. And to let everyone know, you can search and subscribe to the Pumps and Systems podcast on any platform such as Apple, Google, SoundCloud, Spotify, or Stitcher. Want to thank Bill and Ram and John Crane for sponsoring this podcast. Visit John Crane on the web at johncrane.com, JOHNCRANE.com. If you want to reach out to me, the podcast host, please email me, dchamplin@cahabamedia.com. That's DCHAMPLIN at CAHABAMEDIA.com. Till next time, thank you so much for listening.